Hi, it's me Noor Fatma Mansoor, and today in this lesson 5, part 2, we're gonna talk again about sentiment classification with naive Bayes and logistic regression. Finally, we're gonna study about logistic regression, which is really important topic, so I don't want you guys to miss this lesson. So let's get started. So in this lesson 5 part 2, we're gonna talk about sentiment classification with naive Bayes and logistic regression. So these are the highlights for today's video. This is the objective of today's video, and these are the outlines. So first we're gonna discuss what is an API, because we're gonna use it as well. So after that we're gonna discuss about logistic regression and trigrams, bigrams and unigrams, and after that we're going to discuss about n-grams and solve a lot of exercises with it. So let's get started with this to code and learn about these. So first let's discuss about the fast APIs with text datasets. So first let's see what an API is. So an API stands for application programming interface. So it is like a bridge that allows different software systems to communicate and interact with each other, like which enable them to share and exchange data and maybe functionality seamlessly. So it defines how software components should interact and making it easier like to develop applications and other services. So here reviewsful is a label list object. You can see label list. It is a label list object which contains label list objects that train, valid and potentially test. So here we are checking the data type of this label list. Then this code checks the data type of valid subset within the reviews full collection of labeled data. So okay, you can see here we are storing the vocabulary in a variable full vocab like this, and then we are recalling that vocab object that has a method integer to string conversion which returns a list of tokens. You can see here these tokens are bad, people, other, will. Actually what are tokens? Tokens are created, I'm repeating it again because I just told that in the previous lecture, but it's okay. So tokens are actually you can we can't compare both sentences at once. Like we have to create some tokens, like the positive words, like the positive words from a positive review, and like just parts of that sentence to create to make it easier for our computer to compute it. So here are those tokens. Like see, bad would be in a would be in a negative review. People should be in like either positive one or negative one. Then will, other also, and some other tokens. So a label list, sorry, okay. So a label list objects contains a text list object X and a category list object Y. So then a text list object, a list of text object containing the reviews as items. See here, so you can see, and then a text list has object, let me see here, okay. Then the text list object also has a method called items which returns the integer array representations for all reviews. This code actually retrieves the data type, not the data type actually, let me see where it was because that one is important. See here, okay, sorry, I just goes down too much. So okay, so first, because this step is important, so here it first retrieves the data type of our first element x00. Means the first index because computer starts counting from 0, as you know. So within the valid subset of the reviews full label data collection. So then a text object has properties text, which is str containing the reviews text, and data, which is an array of integers representing the tokens in the review. Pretty simple. Then review labels are stored as category list object, which is also simple. Object has a list of category objects. Okay, So this is the level of the first review, seems right. So C, category neg. You can see names of classes, we get negative and positive classes. We made two classes which are negative and positive for each review. So number of classes, which is 2, and then the classes have both integer len and string representations, you can see here. And then the training and validation data sets each have 25,000 samples. You can see the shape of that, actually not the shape, the length. So then our next exercise is 12, the naive Bayes classifier with the full IMDb dataset. So okay, so data exploration with low count ratios, we studied about it. So the token likelihood condition on class is actually like these lines actually compute normalized ratios L1 and L0 based on counts of positive and negative labels in our data. So now this line simply calculates a low count ratio, which we talked about in the last class. So let me just describe it again in simple words. So the log count ratio is actually a measure of how much a word is associated with a certain class or category of documents. So it is calculated by taking the logarithm of the ratio of the word's frequency in one class to its frequency in another class 12. So for example, let me give an example. So it would be more cleaner and easier to understand. So for example, if a word appears more often in positive reviews than in negative reviews, so like it will have a high log count ratio. A word that and then a word that appears equally often in both classes will have a log count ratio of 0. So as here we can see, I had some, yeah, okay, you can see checking the log count ratios are negative for words with negative sentiment and positive for words with positive sentiment. So see here, for hated it's in the minus number, which shows that it is a negative one because it is the negative number, right? So then we get some positive one. Loved is a positive word, so it is showing that it's 1.15 something. So it is a positive word because it doesn't look like a negative one. And then we have like, which is also positive, worst, which is negative, best, which is positive. So as I told, the number of positive reviews in the data sets are equal. So actually which means that the bias is 0. It is non-biased data. We have a non-biased data. So then okay, this 12b. So predictions of the naive Bayes classifier for the full IMDb dataset. So we get much better accuracy this time because of the larger training dataset. So this can train our model very well. So this code employs, so actually what this code does, it employs a naive Bayes classifier to predict validation labels using calculated weights and bias, calculating the accuracy. You can see here we are calculating the accuracy, so and displaying the result for the IMDb dataset. So you can see, so the validation accuracy is 0.83292, so 3292 for the full dataset. So yeah, so the so our next exercise 13 is about the logistic regression with classifier with the full IMDb dataset. So with the scikit-learn library, we can fit logistic regression model where the features are the unigrams. Here C is a regularization parameter. So like this we import the logistic regression, so from sklearn, scikit-learn. So you can see first we are importing from sklearn.linear model, import logistic regression, pretty simple. Then using full document time matrix. So let me explain what is actually logistic regression. So logistic regression is a statistical technique used to model up the probability of a binary outcome based on our input features. So this is how we import, and then we are gonna use that full term document matrix. So what this code does, okay, so this code does is actually this code trains a logistic regression model with specific settings. You can see some settings we have in this code on the training data. First we train, so let me tell you how we train and test our data. So when training a model, so we use 80-20 rule. So 80-20 rule is actually 80% we use, because we cannot just give all the data to for our training model, and we doesn't know that how our model is trained. We don't know that how our model is trained. We don't know like what is gonna happen like when we're gonna test it. So we don't have much data left for our testing data. So first we do 80-20 rules. So 80% data for our training, and then with the left 20% data we just test our data and then start doing our operations. So this code actually trains a logistic regression model with the specific settings as I told on the training data, and predicts validation outcomes using the model, calculating and printing the validation accuracy for our IMDb vocabulary. IMDb vocabulary dataset. No, sorry, IMDb dataset. We have that ahead. So accuracy is 0.88328. You can see using the full document term matrix. Then this is binarized document term matrix. Get a slightly higher accuracy. We can get lot more better accuracy with this. You can just see it because it is pretty simple and a kind of similar with the previous one. So now over exercise 14, trigram representation of the IMDb sample pre-processing. Pre-processing, what is pre-processing? So pre-processing is actually when we have data. Let's say we collect data from we get some data from a hospital of some patients, and the doctor, maybe some about the doctor. So what we're gonna do is, maybe the data has so much noises in it, noises as in like unlike data that we don't like, and we're not gonna use it in. So to just clean our data and get the valuable information from it is called pre-processing. We do it before training our data, training our model. So it gets easy for our computer and model to understand, because with the when we not do pre-processing, our data is so much like mixed and messed up, and it is really hard for our model to calculate the things and just do the operations on it. So maybe the accuracy rate comes down with that. So our next model is a version of logistic regression with naive Bayes features extended to include bigrams and trigrams as well as unigrams. So for every document we compute binarized features as described above. So but this time we're gonna use bigrams and trigrams too. So each feature is a log count ratio. A logistic regression model is then trained to predict sentiment. Because of much larger number of features, we will return to the smaller IMDb sample dataset. So what are n-grams? So let me explain it. So an n-gram is a contiguous sequence of n items, where the n items are where the items can be characters, syllables or words. So 1 gram is a unigram, and here we are referring to the sequences of words. You can see. So examples of bigrams include the dog, said that, and can't you. So 1 gram is actually a unigram, and I didn't explain that. And a 2 gram is a bigram, and a 3 gram is a trigram. As you can see, uni stands for 1, as we have also studied in science, unicellular and bicellular, so multicellular, sorry. So uni means 1, bi means 2, and 3 means tri means 3. So you can see we have unigram, bigram and trigram. You can see here. So about our 14A exercise, sorry, that gets down. Okay. So the first exercise is about getting the IMDb sample. So again we find that accessing the text list API sometimes. So about 50% of the time, that throws a broken process tool error. This is puzzling. I don't know why it happens. So but it actually works at on your first or second try maybe. So try running this code. I have run this code here so you can see. Excuse me. So yeah, IMDb vocabulary. So sample vocabulary. So here what we're gonna do is you can see it and it has like 6016 tokens in it. You can see that's pretty simple. Then so exercise 14.b is about creating the n-gram document matrix for the training data. So just as the document turn matrix encodes the token features, the n-gram document matrix encodes the n-gram features. So this code what it does is, let me see. Okay, it's pretty simple. So this code sets up data structures for representing n-gram features by initializing some variables. You can see and dictionaries for encoding the not dictionaries for the list, initializing variables and list for encoding n-grams in a document level matrix. So we will iterate through the sequences of words to create our n-grams. This takes several minutes, so wait for it when you are running it. So what this code does is, let me explain. This is pretty like a kind of maybe puzzling for you. So this code first it does is loop through the documents. For the code iterates through each document in the training set of movie reviews. Then it extracts the token features for each document, creates a counter of token features for our token features, words or tokens present in the document. Then what it does is generate n-grams and update dictionaries. So what it does is like it generates n-grams of different lengths from min n variable. It was somewhere here, I don't know where. So but I know what this code does because I have wrote this code. So from min n to max n from the token features. So it checks if each n-gram is present in our dictionaries, n-gram TOI and ITO n-gram. You can see somewhere here. Yeah, here ITO n-gram. Okay, and the n-gram TOI. Then if not, it adds the n-gram to the dictionaries with a corresponding index, which is pretty simple. Then it tracks the n-gram occurrences. The code then compiles the indices of the n-grams found in the document, incrementing counters and dictionaries accordingly. So after that it is updating the data structures, the j indices values, the j indices over values, so j indices values and INDPTR. So INDPTR data structures and are updated to include the n-gram information, which will be used to create a compressed sparse row matrix representation of the n-gram features. So in essence, this code processes each documents to extract the n-gram features and maintains dictionaries and data structures to efficiently represent these features for later use in the matrix representation. So using dictionaries to convert between indices and strings, in this case for n-grams, it is a common and useful approach. So here we have created ITO n-gram index to n-gram, which stands for index to n-gram, and n-gram TOI n-gram to index. So dictionaries, this takes a few moments. So this again takes a few moments because it is all about processing. You can see here. So this what this code does is, let me see. Okay, so this code creates a sparse matrix representing n-gram features using pre-computed values and dictionaries. So the next exercise is pretty simple, I know that. Yeah, this one. This is pretty simple, so you can cover this after the lessons video. So now in the next exercise, what we have, yeah, this is a kind of puzzling maybe. So now in the next exercise, we're going to create the n-gram document matrix for the validation data. Let me briefly explain this code. Let me first see what is happening here. Oh yeah, I remember. Okay, so in this code, this code actually constructs a sparse matrix for n-gram features in the validation data. It processes each document similarly to the training data set, then building index value structures and updating them to create the matrix representation. So then we have 14e, saving the n-gram data, so we won't have to spend the time to generate it again. So here what it does is, this is how we save the n-gram data. So these lines actually, this line, these lines and these lines. So these lines actually first save the sparse n-gram document matrices for training and validation in compressed format. Okay. So then they have saved it to index to n-gram. See here, index to n-gram and n-gram to index. You can see here. So dictionaries using pickle library, ensuring efficient storage and future data retrieval. So this is also pretty simple. 14f, this is actually about loading the n-gram data. So now we are loading the data in the same way, but using the function to load. So now let's go to 15. So 15 exercise is about a naive based IMDb classifier using trigrams instead of tokens. So it would be easier. So yeah, first it is this one. Okay, so numerical label representation. So this code actually assigns the numerical representations to the positive and negative labels and then prints the numeric values for those labels. Let's see. Yeah, so representing numerically by 1 and 0, you can see it. Okay, so Boolean indicators for positive and negative reviews in the training set. So yeah, it's pretty simple. Boolean indicators for positive and negative reviews in the training set. Then 15a, naive Bayes with trigrams, which is also simple, you can see. Excuse me. So yeah, the bias and the input in the is the n-gram document matrix that we studied. It's just the some modified version of that we studied before. Pretty simple. So yeah, let's see the next exercise, 16th exercise. So 16th is actually about a logistic regression IMDb classifier using trigrams. So first what we're gonna do is we just import it. So like first we import the logistic regression, then we import from feature extraction.txt the count vectorizer, sorry. So just a second, with this okay. So 16a is about using the count vectorizer to create the train n-gram document matrix. So first we are checking the shape. You can see where we are checking the shape. Actually, let's see, we were checking it somewhere. I remember because I wrote it. Okay, so let's skip it. So over train n-gram document matrix, then fitting a model to binarize trigram counts. This is like simple. Okay, so binarize trigram counts. So full trigram counts, and yeah, in this exercise, actually in 16b, this time over n-gram counts to create the trained and n-gram document matrix. Yeah, in this we are checking the shape because I just jumbled it because it was in my head messing around. So yeah, we're just checking the shape and then fitting a model to binarize trigram counts. See, Then 16C exercise, which is about logistic regression with the log count ratio, which gives a slightly better result. So see, first what we are doing is first we are computing the log count ratio R and bias B, which is R and bias B. Okay. So then in this scenario we train the logistic regression model with regularization, where we input the features. Where we input features consist of log count ratios associated with trigrams. So yeah. So our exercise 17 is a summary of our review sentiment classified results. So let me summary this, which is pretty simple. So for me to summarize, so this code actually generates, see here. So this code actually generates an HTML table using the tabulate package to display a comparison of different models, datasets, and token units with their respective validation accuracy percentages. See here, we have some percentages here, and over table names, and then it summarizes model performance in clear tabular format. And after it, in the end, I have referred to all the references may be used in this lesson. So this is it about today's lesson, which was lesson 5 part 2. So till then, take care, bye bye, keep exploring and keep learning.